All right, so let's continue. Problem number 18. Let's read the directions. Indicate how the graph of each function is related to the graph of one of the 6 basic elementary parent toolkit. You get the point. Functions by describing the transformation. Is it a vertical shift, a horizontal shift, a reflection, a vertical stretch compression, or horizontal stretch or compression? Okay, so what is the basic graph? That's one thing I want to know. I didn't say it right up above, but when I say that, I want to know what is the basic graph. So the basic function or the toolkit function is f of x. You strip everything away. Any addition, subtraction, multiplication, or division should be completely stripped away. And when you do that, you're only left with x squared. You see that? So if I get rid of the minus 4 and the minus 6, I still have an x squared. That's the basic function. Now, the minus 4 part has moved the graph right 4. That is called a vertical shift. Actually, that's called a horizontal shift. I said that backwards. Because right, left, is horizontal. We've moved down 6. That's the vertical shift. Up and down is vertical. Okay. I have not reflected. How do I know that? Because there would have to be a negative multiplied by the x or a negative multiplied by the entire function. So there are no reflections. So reflections, none. You know what? There's also no stretch or compression. Why do I know that? Because I'm not multiplying the x by any value or multiplying any value up front. Okay? Now I'm supposed to take my basic graph, which is right here, f of x equals x squared, and move it right 4 and down 6. How hard is that? We can totally do that. So I'm going to go right 4, 1, 2, 3, 4, down 6. So now the vertex, or that low part of the parabola, is right there. But now I should graph some more points. Like probably a good point to plug in might be a point on either side. Okay? So we have x and y. So that point right there is x equals 4. So why don't we plug in x equals 3 and maybe x equals 5. Okay, if I plug in 3, that's going to be 3 minus 4 squared minus 6. 3 minus 4 is negative 1. Negative 1 squared is 1. 1 minus 6 is negative 5. And then plug in 5 minus 4 squared minus 6. Just a t-table, y'all. 5 minus 4 is 1. 1 squared is 1. 1 minus 6 is negative 5. Is it a coincidence I got negative 5 for both of them? No. When you're doing a parabola and you pick a point on each side of that low point, then you should get the same y value for both of them. Now, don't assume. Ow. Yeah, I'm sorry, I had to get my battery plugged in. But anyway, don't assume they're going to be the same on both sides. Actually plug it in. But what I would do is take your point that you move left, right, up, down, and plug in a point on each side, except for square root graphs. And I'll talk to you about one of those in just a minute. And you'll get a decent looking graph, like we did right here. Let's try another one. Okay, so on the test, I might ask you, what is the basic function? And then I might ask you, what is the vertical shift? And then I might ask you, what is the horizontal shift? And then I might ask you, what is the reflection? And then, is there a stretch or compression in the vertical direction? And then, is there a stretch or compression in the horizontal direction? And you've got notes that cover this. Okay, so I might ask you all of these things. So the basic graph of absolute value of x plus 2 minus 3, and again, basic graphs means you peel away all the addition, subtraction, multiplication, division. Well, if I do that, that just leaves me with f of x equals the absolute value of x. Is there a vertical shift? Vertical means have I moved it up or down? And I have. I've moved it down by 3. So don't just tell me down by how many. Is there a horizontal shift? That means have I moved it left or right? Yes, I have. I have moved it left by 2 units, because that's what that plus 2 means. Is there a reflection? There is not. How do I know? Because there's no negative times the x, and there's no negative times the function value. Is there a vertical stretch or a vertical compression? No, there's not. What would that look like? You might have negative 3 absolute value of x plus 2 minus 3. That right there would be both a reflection in the x-axis and a vertical stretch by 3. So you need to multiply to have reflections and stretches and compressions. Okay? We don't have that, so no to all of those. Now, I want a graph. And to graph your first point, this is what you're paying attention to. Okay? You want to do your left, right, up, and down stuff. So you go to 0, 0, right in the middle, and we move left 2 and down 3. That means that's going to be my V. The bottom of my V or the top of my V if there was a reflection. But there is no reflection, so it's the bottom of my V. Now, what do I want to plug in? Hey, a number on each side, right? If I plug in, so that's x equals negative 2. What about if I plug in negative 3 and negative 1? So I have the absolute value of negative 3 plus 2 minus 3. That's going to be the absolute value of negative 1 minus 3, which is positive 1 minus 3, which is negative 2. I'm running low on space, so there's a negative 2 right there. Okay, next point, I'm plugging in negative 1. So that's the absolute value of negative 1 plus 2 minus 3. That gives me the absolute value of positive 1 minus 3. Well, the absolute value of positive 1 is 1. 1 minus 3 is also negative 2. Is that a coincidence? Well, no. For an absolute value, just like the parabola, you're going to get the same point on each side. When I connect the dots, there's my graph right there. All right, so 18C. Now, we need to know, remember, the basic function. That's where you always start this process. So what is the basic function? Is there a vertical shift? Is there a horizontal shift? Is there a reflection? Is there a stretch or compression in the horizontal or in the vertical? Well, let's start with basic. Basic means you trim away any addition, subtraction, multiplication, or division. If you do that in this particular case, you're just left with the square root of x. And we know what that basic graph looks like. It looks like that. Okay? A vertical shift means we moved up or down. Now notice I rewrote this problem for you so you can see that they're really the same thing. We're used to it in this form over here to the right rather than over to the left, but they really are the same thing. We just put the minus 2 in the back. And what we know from that is we have moved the graph down 2. Remember, whenever you have addition or subtraction outside the function, that's up or down, and minus is down. If it was plus 2, it'd be up 2. Now, the horizontal shift, that's left-right, that always is what you're doing to the x value. That plus 3 actually moves us left 3 units. Is there a reflection? No, because we're not multiplying by a negative outside or inside the function. So once again, no reflections and no stretches because we're not multiplying the x by value outside or inside. Again, these guys, if I took this problem and did that, it might be the square root of 5x plus 3 minus 2. That value right there would give us a horizontal compression. But we don't have any of that multiplication. So we don't have any of that. So none on the stretch compression. Now, let's graph. Now, I've got to move this main point right here, okay, I say right here, I'm talking about this guy right here, 0, 0. I'm going to move that point down to left 3. So let's do that. So if I move that point down 2 and left 3, it is right here at negative 3, negative 2. And my arc is going to be over to the right because I haven't reflected it. Now normally I was asking you to plug in a point on each side. Well, don't in this case, because if you go to the left, you're not going to even be able to plug that value in. So my suggestion is points on the right. So again, you could try on the left, but you're going to get an imaginary number, because when you plug in negative 4, you're going to have the square root of negative 1. We can't do it. So let's plug in like negative 2, negative 1, 0. All those would be good values. So... and again, I'm going to use the one on the right because it's easier to look at. So that's going to be the square root of negative 2 plus 3. All that's under a square root. And then we're going to subtract 2. So that's equivalent to the square root of 1 subtract 2. We know that the square root of 1 is 1. 1 minus 2 is negative 1. So that answer that is negative 1. Now I'm going to plug negative 1 in. Okay, so that's the square root of negative 1 plus 3 minus 2. Now, negative 1 plus 3 is 2, so that's the square root of 2 minus 2. Now, that's a calculator problem right there because square root of 2 is an irrational number. It's about 1.4. So 1.4 minus 2 is going to give you almost negative 0.6. I'm just going to round it to negative 0.6. And then I'm going to plug in 0. So that'd be the square root of 0 plus 3 minus 2. Okay, well the square root of 0 plus 3 is the square root of 3 minus 2. Y'all, I don't even know what that is without a calculator, but you know what? If I plugged in 1, I'd get a nice number, wouldn't I? The square root of 1 plus 3 minus 2, which will be the square root of 4 minus 2. Y'all, what's the square root of 4 minus 2? 2 minus 2, which is 0. So I'm going to skip that one with the square root of 3 and just plug in that instead, okay? So I've got my first point in green over there, and now I'm going to plug in negative 2, negative 1. That's right there. And then negative 1, negative 0.6, the best I can there. When I plugged in 0, I didn't like that number. 1, 0, right there. And that is plenty to tell that I have my arc over like that. Remember, you don't have an arrow on this end because square roots have a beginning point. All right, let's do some more of these. And notice this doesn't match what you have. Well, the typed part doesn't. I had to squeeze the 2 in there, and now it matches what you have in your problem list. But we have f of x equals 2 times x plus 4 to the third plus 5. So what is the basic function? Well, the basic function is going to be if you strip away all the addition, subtraction, multiplication, division, and that's just going to leave you with f of x is equal to x to the third. That's the basic. Now, have we moved it left or right, or up or down? And let's do up and down first. Notice the plus 5 on the outside, so that's up 5. That's your vertical shift. The plus 4 on the inside would mean we move to the left 4. That's your horizontal shift. There is no reflection. Why not? Because there is no negative times the x or a negative out front. But there is what we call a vertical stretch. So notice we stretch the graph out. We have a vertical stretch by 2 right here, because whenever you multiply the function times a value bigger than 1, it is a vertical stretch. Had I made that a 1/2 or some value between 0 and 1, that'd be a vertical compression. There is no horizontal stretch or compression because that would be multiplying the x by some value. And we're not multiplying the x by value, we're multiplying the x plus 4 to the third by a value. All right, you ready? So the up 5 and left 4, that's the part that you put on the graph right off the bat. Okay, so we're going to take our regular x to the third graph, and you may need a little reminder of what that looks like. That's a regular x to the third. And we're going to move that point right there at the origin, up 5 and left 4. So now it's right here. Okay, and by my suggestion, I suggest always plugging in points on each side of that point, except when you're dealing with square roots. When you're dealing with square roots, you can only plug in points on one side. But that is x equals -4, so let's plug in x equals -5, and let's plug in x equals -3. And remember, we've already got -4 plugged in. Where am I plugging that into? The original function. So I've got 2 times -5 plus 4 to the third plus 5. That's what I'm calculating. I'm going to do this in my head because I'm running out of space. -5 plus 4 is -1. -1 to the third is also -1. Times 2 is -2. Plus 5 is 3. Now I'm going to plug in -3. So it's 2 times -3 plus 4 to the third plus 5. So listen to me again. -3 plus 4 is 1. 1 to the third is +1. +1 times 2 is 2. 2 plus 5 is 7. So I'm going to plot those points also. So -5, 3. 1, 2, 3 right there. And -3, 7. Which is there. Now, those are always going to look like a straight line when you plot points next to each other. But you got to remember the shape. It's that kind of sniggy shape. I make it look like it goes all the way up, like straight up. Y'all, it doesn't really. And it's when it's steep like that, it's really hard to make it look like it arcs forever in one direction, but it does. I think I did a better job the first time. But you see what I mean? That's not a straight line connecting those. It curves down and it curves down. It curves up on the right and it curves down on the left in this particular graph. Okie dokie. Let's keep going. Okay, so for our next problem, like we've been doing every time, I want to discuss what is the basic graph. Does it have a vertical shift? Does it have a horizontal shift? Does it have a reflection? Is there a vertical stretch or compression? Is there a horizontal stretch or compression? And I'll make sure I ask it like that on the test so you address every one of these. Okay? So, what is the basic function? When we take a look at this, if I trim away all the addition, subtraction, multiplication, division, all I'm left with is f of x equals the square root of x. And it helps to know what that basic graph looks like, which is that right there. Now, is there a vertical shift? Those happen when you add outside the square root in this case, so there's not one. Is there a horizontal shift? That happens when you add or subtract inside the square root or add or subtract to the x. There's not one. There is a reflection, and this is a reflection in the y-axis. So when you multiply your x value times a negative, that's a reflection in the y-axis. If the negative were out front of the square root, that would be in the x-axis. There is no vertical stretch or horizontal stretch or compression. That would require us multiplying by a number like 1/2 or 2 on the outside for vertical, or by 1/2 or 2 on the inside for horizontal. So there's none of this. That was a whole lot of nones, isn't it? Really, the only thing we're doing in this case is a reflection in the y-axis. That's it. Now, to graph this. So, short little t-table. Now, we know that this is the point that moves around. If we reflect it in the x-axis, in the y-axis, it's going to look like the black line I have there. So, the main point stays right where it is because we didn't move it left or right or up or down. So we should plug in 2 more points. But remember, on a square root, you can't plug in a point on each side. We already know it's reflected off to the left. So if we plug in, for instance, -1, -2, -4, those would be good. If I plugged in -2 or -3 or -5, I would get irrational numbers where I'd have to use my calculator. But here, I've got the square root of, now there's a negative inside that's already there, and then I'm taking out the x and substituting in -1. So basically, that's the square root of negative of a -1, which is the square root of 1, which is 1. Same thing's going to happen with the -4. So negative of a -4 is the square root of 4, which is 2. So I have negative 1, 1, and then negative 4, 2. And there is that arc over to the left. All right, so example F. So we want to indicate the basic graph, okay? So the basic graph, if I peel away all the multiplication, division, addition, subtraction, that just leaves me with f of x equals x squared. Is there a vertical shift? Remember, that's up and down. That's going to be that plus 2 on the outside, so we could say yes, up 2. Is there a horizontal shift? Remember, that's left or right. That's always going to be inside with the x value, and it's right 1. Remember, right is negative, left is positive. Is there a reflection? That's if you multiply the outside by a negative or the inside by a negative. Look, yes, there's a reflection in the x-axis. When the outside is a negative number, it could be just a negative 1 implied, or it could be, like in this case, a negative 3. That's going to be an x-axis reflection. If that negative 3 were inside with the x instead, that would be a y-axis reflection. Is there a vertical stretch or compression? There is definitely a vertical stretch by a factor of 3. Why? Because whenever you multiply the outside of the function by a value bigger than 1, then you have a stretch. If that was a 1/3 instead, that would be a compression. Now, we don't have a horizontal stretch or compression. That would mean that the 3 would be on the inside with the x value, so there is none here. Okay, so now the only thing that applies to moving that first point is your vertical shift and your horizontal shift. So I'm going to take my graph, by the way, the basic one looks like the parabola, right? And I'm going to shift it right 1 and up 2. So right 1, up 2. There's my parabola now. What do I know about it? It's flipped upside down because of that x-axis reflection. But I don't even have to stress over that. If I just go ahead and do a t-table right now and plug in points on each side, that's going to handle my reflection and my vertical and horizontal stretch if I have them. Okay? All right, so here we go. What do I want to plug in? We've got 1, so hey, let's plug in 0 and maybe 2. 1 on each side of this x value of 1. So when I plug in 0, that's going to be negative 3 times, by the way, I changed, look, don't look at this problem right here. I changed it to the one in pink. Your paper says the one in pink. So negative 3 times 0 minus 1 squared plus 2. So we do inside first. 0 minus 1 is negative 1. Squared is 1. 1 times negative 3 is negative 3 plus 2 is negative 1. And then I plug in 2. So negative 3 times 2 minus 1 squared plus 2. So 2 minus 1 is 1. 1 squared is 1 times negative 3 is negative 3 plus 2 is, again, negative 1. Now we should have expected that because we have a parabola. So it's the same on each side. So 0, negative 1 is here. And then 2, negative 1 is here. And here's my parabola shape. Notice how it's skinny because we stretched it by a factor of 3, so it's skinnier than your regular parabola. And there you go. Let's do one more like this. All right, so for our next example, I had to rewrite it. F of x equals negative square root of 1/2 x. So the basic graph, if we remove all the addition, subtraction, multiplication, and division, which basically gets rid of this negative and this 1/2, that leaves us with f of x equals the square root of x. Is there a vertical shift? The answer is no or none, because you would have to have a plus or a minus outside the square root for that to happen. Is there a horizontal shift? No again there, because you would have to add or subtract to the x value. The only thing that's happening to the x value right now is we're multiplying by 1/2. Is there a reflection? Yes. This negative out front, anytime you multiply your function by a negative, that's a reflection in the x-axis. If I wanted a y-axis reflection, the negative would be inside with the x. But when it's outside the function, it's an x-axis reflection. Do I have a vertical stretch or compression? No, I don't. If the 1/2 were outside, in front of the square root, if I move that 1/2 out here, that would be a vertical compression. But because the 1/2 is inside with the x, it is a horizontal stretch by a factor of 1/2. So remember, when things are inside, it's always the opposite of what you think. Like a 1/2 seems like it ought to squish it, but it doesn't. It stretches it. Just like a plus seems like it ought to be to the right. It's not. It's to the left. It's the same idea. So it's a horizontal stretch by 1/2. Okay? Now let's do a t-table. The good news is when you graph this, you really won't have to focus a whole lot on the stretch. That's what the plotting points is about. What you want to do is use this information to move left, right, up, or down. Well, we're not. So we know that the basic graph, which looks like this, has been reflected through the x-axis. So now it's going to look upside down like that. And that's going to help us pick out points to plot. So what do you want to plug in? Well, we're going to keep that 0, 0 point there because we didn't move left, right, up, or down. And then I'm going to plot, why not plug in 1? But notice, you might not like that. Let's plug in 2. Let's plug in 4. Let's plug in 8. Let me show you why when we do it. So I have negative the square root of 1/2 times 1. That would be negative the square root of 1/2. Well, that's going to give me a decimal. And you may or may not want to fill with that in your calculator. But these values are going to give us better numbers. So if I do negative the square root of 1/2 times 2, that's going to be negative the square root of 1. Well, we know the square root of 1 is 1, so overall that's negative 1. Then negative the square root of 1/2 times 4, well, that's going to give me negative square root of 2. Now, I do know that my calculator is about 1.4. And then negative the square root of 1/2 times 8 would be negative the square root of 4, which would give me negative 2. So I found some better numbers to plug in. That's why I picked those. Okay, so 1, I didn't want to fool with that one, although you could type that in your calculator. When I plugged in 2, I got negative 1. When I plugged in 4, I got negative 1.4. And when I plugged in 8, I got negative 2. And there we go. That's enough to give us a really good looking graph. And then it arcs over to the right there. And there you go. Okay, folks, I think this is the last one of these. And so what is my basic graph here? Well, I strip away all the addition and subtraction, which means getting rid of the 2, getting rid of the 1. That's just going to leave me with f of x is equal to the cubed root of x. Remember what that looks like is kind of like that. Okay? Is there a vertical shift? Have I moved this up or down? And I have. That plus 1 on the outside means we have moved up 1. Is there a horizontal shift? Yes, that plus 2 on the inside means we have moved left 2. Is there a reflection? No, we haven't multiplied anything by negative, so no reflections in the x or the y-axis. Is there a vertical stretch? No, I haven't multiplied by any values on the inside with the x or multiplied on the outside. So none of that stuff. All right, now let's do a t-table. Okay, now remember, when you first move your point, this is what we're focused on. I need to take my point that's common to every one of my graphs, that point at 0, 0, and move it up 1 and left 2. So up 1, left 2, moves it right there. And then plug in a point on each side. And the only time I don't plug in a point on each side is when I have a square root. But when you have a cube root, that's perfect. So I'm going to plug in negative 1 and negative 3. When I plug in negative 1, it's going to give me the cubed root of negative 1 plus 2 plus 1. All that part's under the cube root, so I add that first. Negative 1 plus 2 gives me the cubed root of 1 plus 1. The cubed root of 1 is 1, plus 1 is 2. Then I'm going to plug in negative 3. So negative 1 plus, I messed that up, negative 3 plus 2. There we go. Negative 3 plus 2 plus 1. Now it's going to give me the cubed root of negative 1 plus 1. The cubed root of negative 1 is negative 1 plus 1. When I add those, I get 0. So I've got negative 1, 2, and negative 3, 0. And remember, that's not a straight line. It's very similar to my cube root graph. It curves right there in the middle, and there's your graph. Okay, so finally, a different kind of problem. So we've got 2x plus 3y equals 6. I'm going to find the x-intercept, the y-intercept, graph, and how do you know the shape of the graph before you graph it?